Hello everyone, I'm Adib, and yesterday I was wondering how do autonomous vehicles actually work? For example, how do Teslas work, or all of those BYD vehicles. So I pretty much had the assumption that they used like a mixture of two technologies. One is LiDAR, the other one is Doppler. But I, did some digging and I found out that they actually use something quite different. It's like a camera plus AI, but I do assume that these cameras would probably have like some sort of infrared plus the on-device computational chips for Tesla. I mean, they're probably going to be really good, right? So most of the other companies, however, they do use a mixture of LiDAR for raycasted depth, and they use Doppler in order to measure the velocity. So I was thinking about like how do I, if I were to ask, if someone were to ask me like how do you build something like the ML infrastructure, or how do you collect data to be able to train something like a Tesla, or, like an autonomous vehicle system. I would say that I would collect the data of LiDAR plus Doppler together in order to form a triangulation to do some sort of obstacle classification. So I wanted to just build like a simulation that would, give me a visualization over this idea. So yeah, I built something called Sinclair. It's like another side project that I've been doing. I've been on a streak of side projects recently. So yeah, let me just show you what I have done. So it's a very simple Rust application. Yeah, so this is what I did. It's called Sinclair. It's a very simple combination of LiDAR and Doppler. How would it look like if they work together, and how would obstacles be viewed in the eyes of these two technologies. So yeah, this is Sinclair. I just started it, and I'm just going to quickly pick a location. So these all are coming in from real satellite and geolocational data. Yeah, it's pulling all the data from OpenStreetMap, so it's all open source. So I'm just going to click on San Francisco, and yeah, I have this. It's a very simple isometric view, isometric perspective. So it's sort of like one of those 2.5D platformers. It's not completely 3D, but I can pretty much see like the shadows and the ceilings and stuff like that. So yeah, that's that. But the main thing is that first of all, I can see the heat maps. Well, I'm gonna have to collect some data to see the heat maps, and I can also see the real map. So where I exactly am. So this is, like I said, 500-meter of San Francisco's map, right? So I'm gonna start capturing, and as you can see that I can see almost like how would LiDAR work, and it's hitting all of the obstacles, it's hitting all the buildings, it's going and working with some random heights, and these very poorly drawn boxes are actually they are supposed to resemble cars. But here's the interesting bit. So I can change sensor models. So right now I'm just working with the Velodyne VLP16, which is like a pretty simple LiDAR sensor, and I can just start driving to see how does it actually work. So yeah, this is all of the effect. This is how LiDAR sees in real time, right? So, and this also starts to accumulate and build up a heat map of the data. So this is how the cars actually see what's going on around them. So all the buildings, all the cars, and how exactly the velocity is catching up to in context of the proportion of the vehicle's speed, right? So the velocity of other objects that are moving in real time. So this is quite an interesting project, and I can just go back to the normal view, and I can see like different sets of views. I can change and move around the perspective. So this is a pretty interesting view of what's actually going on, right? So I'm going to change the sensor mode to a much stronger sensor, and yeah, this is all being rendered on CPU. So this is nothing really fancy or performance oriented going on. Of course, however, I can switch to the easier sensor, which is Velodyne VLP16, and I can then switch to, this is all the ray tracing that's going on. It's supposed to represent LiDAR, and I can just press X in order to get the Doppler effect. So this is how the Doppler is seeing and working with collaboration of LiDAR, right? So if I just switch off LiDAR, this is what is going on. So the heat maps that are changing, it's supposed to represent the obstacle versus the velocity, and there's like a heat map, there's like a legend that's giving you the idea. So as you can see, everything is plain white. That means the car is the car is present, but when I move around, you'll pretty much see like the Doppler, which is in effect of the obstacles around it. And like I said, I can also turn on and turn off the heat map, which is pretty interesting, which is the most interesting aspect of this tool, to see like how it is working, in the eyes of these sensors. So I can turn on the LiDAR again. I can switch to a much stronger one, and yeah, this is pretty much the actual accumulation. Quite an interesting thing this is. And of course, you can always export all this data, in various formats. So this is pretty extendable if you want to make this extendable, and also has an autoplay mode, which is pretty funky. It's not really perfect, but this is quite funky. But let me just show you guys how it works. So it just moves around, but the heat map effect, I like that one with this thing. I'm just gonna switch to the much easier sensor, and you know what, I'm just gonna go to manual because this is pretty not really the most beautiful thing out there. So I can just switch and play around the map, and of course I can load other maps, but it's gonna have to download, and the download takes some while, so I'm not gonna show that. And yeah, everything, oh sorry, I've been hitting that. But everything else is this is pretty straightforward, to be honest. So yeah, just wanted to share this small little project. I will leave all of the open source links around the posts that I'm gonna share. So yeah, thank you. Thanks everyone for staying with me. Bye bye.